use. Example 1 says 4 friends share a 2-bedroom apartment in downtown LA, and each one has at least 1 pet. Narek has a dog, John has 2 cats, Jose has 2 snakes, and Anthony has 3 tomato frogs. Assuming that 2 of the friends are randomly selected with replacement, so we could choose Narek or any of the others twice, list the 16 different possible samples. We could have a sample of 1 and 1, or of 2 and 1, 2 and 1, or 3 and 1, 1 and 2, 2 and 2, 2 and 2, or 3 and 2. The same here, 1 and 2, 2 and 2, 2 and 2, 3 and 2, or 1 and 3, 2 and 3, 2 and 3, and 3 and 3. Those are all of our possible 16 different samples we could have. Then it says, okay, now can you find the mean of each of these samples? So to find the mean of these 2, we're going to add them together. 1 plus 1 divided by 2, we end up with 1. And then 2 plus 1 divided by 2 gives us 3/2, and so on. And those are the means of all of the different 16 samples. Then it tells us to represent this as a probability distribution. A probability distribution is just a table. We're going to have our mean and then the probability of that mean occurring. We have a mean of 1, and there is 1 out of 16 different options there. We got a mean of 1.5, or 3/2, and there were 1, 2, 3, 4 of them, so 4 out of 16. We got a mean of 2. There were 1, 2, 3, 4, 5, 6 of them. And we got 5/2, or 2.5. There were 4 of them. And then we got a mean of 3. There was 1. Part C here says to compare the population mean to the mean of the sample means. Thinking back to chapter 5, the way we would find the mean of all the sample means, we could either add them all up and divide by our total number, or we could multiply x by the probability of x and then add those together. Our population mean, mu, is going to be the sum of all of the items in our population. Well, our population is 1, 2, 2, and 3 divided by 4. Our population mean ends up being 8/4, which is 2. That is our population mean. And now we want to find the mean of all of our sample means. 1 times 1/16 plus 3/2 times 4/16 plus 2 times 6/16 plus 5/2 times 4/16 plus 3 times 1/16. The mean of all of our sample means is going to be 1/16 plus 6/16 plus 12/16 plus 10/16 plus 3/16. And that gives us 32 out of 16, which is 2. This is the mean of all sample means. When you look at it, you see that the mean of our population and the mean of every possible sample of size 2 is exactly the same. They are equivalent to each other. Part D asks us, it says, do the sample means target the value of the population mean? Yes, they do. We can say, yes, the sample means target the value of the population mean. If we look at it and we see our population mean is 2, when we look at our possible sample means, we had 1, 1.5, 2, 2.5, and 3. Some of them were equivalent to our population mean. Some of them were a little bit below. Some of them were a little bit above. But overall, because we have some that are below and some that are above, when we average them or take the mean of all of those different sample means, we end up with the exact same mean as our population. In this example, we did get our population mean as some of our sample means. However, in some examples and in some situations, none of your sample means would be the same as your population mean. However, once we average all of those sample means, we would end up with the population mean. So sampling means target the population mean. It doesn't systematically overestimate or underestimate. That is why we consider it an unbiased estimator, because we can take the mean of a sample and it is going to be very close to the mean of our entire population. In this example, we had a very small a very small population. However, if we have a sample of size 30 or above, we end up with our sample mean being almost exactly the same as our population mean. So the underlying concept is that the sample mean is going to be a good estimator for the population mean. We will talk about other statistics, whether or not they are targets for the population or not. Some of them are unbiased, and then some of them are biased estimators. And we will have to fix those biased estimators in order to use them to talk about our population.